I am Sam, your teacher, Sam, my teacher, Sammy teacher. Exponent rules are important. There's no arguing about it. It's important throughout learning of math. But it's not a good idea to memorize them without even understanding them. It's always better to learn how they came out. And it's pretty simple too. But before we jump right into it, let me talk about some basic stuff real quick. When you add the same thing 5 times, the short way of writing this is 5a, which means multiply a 5 times. So we can say multiplying is the short way of adding. And when you multiply the same thing 5 times, the short way of writing this is a to the power of 5, which is also called exponent. So exponent or power can be short way of multiplying. So adding the same things can be multiplying, and multiplying the same things can be an exponent. Okay, let's look at the exponent rules one by one now. The first one, when you multiply two numbers with same base, then you add the exponents, so it becomes to the power of m plus n. Well, let me plug in actual numbers here. 3 for m and 2 for n. So a cube multiplied by a squared. Since this means a is being multiplied 3 times and a is being multiplied twice here. So I can rewrite this as a times a times a multiplied by a times a. This is from this, and that is from this. And since there are 5 a's being multiplied, you can rewrite this as a to the power of 5, which is actually 3 plus 2. Now we see that why we add the exponents when you multiply two numbers with equal bases. Now the second rule, base a to the power of m divided by the same base a to the power of n. And the rule is telling us that we can simplify this into one base a, and you subtract m minus n. Let me use plugging actual values again. Let me plug in 3 for the m again and 2 for the n again. You can rewrite this as, since a is being multiplied 3 times, it will be a times a times a. And same thing here, a times a, because that's twice. And you see that 2 of the 3 a's in the numerator are being cancelled by the 2 a's in the denominator. And that leaves only one a on the top, which is same thing as a to the first power. And that is exactly 3 minus 2. So now we see why we subtract the denominator power from the numerator power, because they become reduced. Now we can use the second rule we just talked about to prove this zero exponent rule. So we will copy this rule down here, but give a little bit of modification. I'm gonna write base a to the power of m and base a to the same power. So the bases are the same and the powers are the same too. And at this point, I have to tell you that a should never be 0, because that will make this denominator undefined. You can't divide any number by 0. So it could be any other numbers except 0. And according to the rule number 2, I can rewrite this as a to the power of m minus m. because when I divide, I subtract the denominator power from the numerator power. So it'll be m minus m, which is obviously 0, right? So this equals to a to the 0 power. Now look at the fraction we started from. Just like 3 over 3 is reduced to 1. Wouldn't these two numbers reduce to 1? Because they're same thing. So this is same thing as 1. And since they are all equal to each other, we can safely conclude that a to the 0 power equals 1. Now the fourth rule is simple too. It says when you have a certain base to the power of m and the whole thing to the power of n, it's telling us to multiply the exponents. Let me plug in 3 for the m and 2 for the n. That equals a times a times a, because a is being multiplied 3 times, and the whole thing is going to be squared. And since you're multiplying the whole thing twice, I can rewrite this as a times a times a and another a times a times a. And altogether there are 6 a's being multiplied. So you can simplify this as a to the 6th power, which is obviously 3 times 2. And now we see why we multiply these two exponents. Well, we have 2 more to go, but you might want to pay a closer attention for these two. The fifth rule says if I have a certain base and the power is a negative number, you can change the negative exponent into positive exponent, but it will be in the denominator, reciprocated. So for example, if a is being powered to negative 2, it will be 1 over a squared. And if you remember what I told you in the beginning part of this video, exponent or power is short way of multiplying. But that's when you have positive power. But now you have negative power. So you have to do something opposite. Then what is the opposite of multiplying? It's dividing, of course. And since you have negative power here, a's will divide instead of multiply. And you know, anything in the denominator divides. That's why we sent a squared into the denominator. So again, power multiplies, but negative power divides. Now finally, our last rule. Again, you have a certain base, but this time you have a fractional exponent, and the variable is in the denominator, and it equals nth root of a. Let's plug in some actual numbers. I will put 8 instead of a and put 3 instead of n. And that should equal, according to this formula, it'll be cube root of 8. You know, when we had the same base, but n power, which is same thing as n over 1, by the way, compare this fraction with this fraction. They're exactly the opposite of each other. And we know that addition and subtraction are opposite of each other, and multiplication and division are opposite of each other. But what is the opposite of power? The opposite of power is root. So the numerator part of an exponent powers, but denominator part of an exponent roots. So if you have base a to the power of m over n, then that will equal a nth root, because denominator of the exponent roots, and since the numerator of the exponent is m, that will power. For example, if you have 8 to the power of 2/3, that's going to be cube root of 8, which is 2, and squared. And the final answer will be 4, by the way. So don't forget, the top of the exponent powers, the bottom of the exponent roots. And that's why a to the power of 1 over n is nth root of a. I hope this explanation gave you better understanding about exponent rules. If this video helped you, it'll be great if you subscribe this channel and you can press the bell button for the upcoming videos. Thank you.